Hey all, we're back with number 2 on the practice exam. It asks us to find the overall impulse response for a cascaded continuous time LTI system. So A wants us to find H1 j omega if H1 of t equals Te minus 2T. So this is straightforward. Just go to your table of Fourier transforms and crank it out. So H1 j omega on the Fourier transforms. This is in table 4.2. So H1 of j omega is going to be and that's because that maps to with the condition that that's true in this case. So now we go to B. H2 of t is given as sine 0.3 pi t. They want us to find H2 of j omega. Again, straightforward, go to your table of Fourier transforms. So this maps to pi j and that's because sine omega not t maps to part C asks us to find the overall frequency response H j omega. We're in the frequency domain, so we know that these cascaded systems here, the overall response is just the product of the two of them. This is kind of the power of the Fourier transform. If we were in continuous time still, we would have to perform convolution, but since we're in the frequency domain, we can just do multiplication. So Hj omega is going to equal h2, so h1 was equal to 1 over 2 plus j omega squared. Okay, we can simplify this. We know from midterm 1 material that one of the properties of the delta function is that it selects the value of the function it's being multiplied with, specifically right here, h1 of j omega. It selects the value of it only at, in this case, since we're in the frequency domain, it would be omega naught. So we can write omega naught here is negative 0.3 pi. Sorry, I forgot the j there. Okay, now part D asks us to find the impulse response h1 of t, h of t. So now we just need to go backwards. So we can go to our table of Fourier transforms, and we know that e j omega naught t maps to 2 pi delta omega minus omega naught. You'll notice the denominator here is no longer a function of j omega, so that's just a constant. That would probably be where you run into difficulty in this problem. You need to make sure that you simplify it using the, let me get the name of this property right, just so I don't confuse anyone. It is the sampling property. I didn't want to get it confused with the sifting property, which is what I was going to say. It is the sampling property. So let's find h of t. and we are gonna get, we need a 2 here, so we can multiply by 2 over 2, so we'll write h of j omega again. Get 2 pi 2j times delta omega minus 0.3 pi 2 plus j 0.3 pi Sorry, hopefully you didn't leave me. I had a couple little small slips in the way I wrote it right here, but I caught them now. Okay, let's reverse this transform to get h of t. We can see it pretty clearly now. H of t equals 1 over 2j times 2 plus j 0.3 pi. We got the EJ omega naught. Omega naught is 0.3 pi t, so minus 2j omega naught, this case is minus 0.3 pi, so minus and that should be the final answer, and it is. Okay, that's number 2 on the practice exam.